the esteemed professors, the departmental lecturer present here today, the PhD, and my co-fellow master students. I'm honored to be here today to present my proposal topic, which is titled Development of Resource Allocation Scheme in Wireless Communication Network. My name is Sulaiman Kasim, and my supervisor name is Professor O.A. Adeleke. My presentation goes thus. Introduction. With the unprecedented growth in mobile traffic communication network, it is very important to take into consideration the optimal use of the limited network resources, and also to increase the quality of service. According to the Cisco report, between year 2021 and year 2023, it was stated that there was an increase of tenfold between this period. As a result of this, there is an urgent need to develop a scheme resource allocation that will maximize the resource that will maximize the limited resources, and also to minimize the wastages. Introduction. What is game theory? Game theory is a strategic decision, and in game theory it can be classified into two. We have the cooperative game theory, which is also termed as non-competitive game theory. We also have the non-cooperative game theory, which is also termed as the competitive game theory. In cooperative game theory, the players have to come together to make a plan and achieve the desired goal. But in non-competitive game theory, the players do not need to come together. As a result of this, they don't need to plan and they do not need to achieve the common goal. These are the definitions of the terms I used. Then these are part of the literature review that I have used. In year 2022, Adeleke et al. Proposed a topic which titled Buffer-Aided Relay Selection Technique in a Cooperative Communication Network. The proposal used in this approach is relay selection technique, whereby the relay nodes integrate with the buffer, and it's okay. Actually this approach enhance the performance in network, but the challenges here is that it increases the latency because of the integration of the relay. Also, in year 2023, Mabuk et al. Also proposed a topic titled Contemporary Advances in Multi-Access Edge Computing, and the approach used here is the integration of the 5G network, 5G technology, Internet of Things, and artificial intelligence. Actually, this approach also enhances the performance and it reduces the latency. But the challenges here is that it overlooks the security vulnerability. As a result of this, it limits the real-world application. Statement of the problem. Effective resource allocation tries to balance the conflicting goals among the different users and the network operators, such as the throughput, the quality of service, and the fairness over wireless telecommunication. Therefore, there is an urgent need to develop an effective strategy resource allocation scheme for wireless communication network using game theory. Research gap. In the recent research work done on bandwidth, it was realized that most of the researchers do not give priority to the network slicing and the cache allocation, and which is very paramount in the network performance, in order to achieve the quality of service and also to reduce the latency. Hence, in this work, development of resource allocation scheme in wireless communication network focuses on developing and evaluating a bandwidth allocation scheme utilizing game theory principles on network slicing and cache storage allocation. These are my methodology block diagram. I have the resource layer. This resource layer will be subnet, and this subnet will be sliced into seven layers. We have the slice layer 1, slice layer 2 to slice layer 7, and each of these layers will be dedicated to different services, such as internet feeding, internet conferencing, internet game, voice over internet protocol, and some other services on the network. So I limited my research to seven services. These are the methodology symbols I used. This now, in order to calculate the total claim by each of the slice, we are going to use equation 3.1, and the excess bandwidth is going to be calculated using equation 3.2. And if the excess bandwidth is less than 0, then we are going to make use of the proportionality rule, which is shown in equation 3.3. And to calculate the total cache size that is needed by all the slices, then we are going to use equation 7. Now, in order to achieve the balance in the balance in the coalition of all the players, then that's what we call Shapley value. This Shapley value will be used to ensure that each of the players are satisfied according to their decision making. And in order to do this, we must follow 3 rules. The rule 1 is called efficiency theorem, which is shown in equation 3.13, and rule 2 is called linear or additivity theorem, which is shown in equation 3.14, and the third rule is shown in equation 3.15. These are my methodology block diagram 2. After the processes above has been done, then all the players are going to receive their all the players are going to channel their request to the cache space kernel, and from this kernel is going to forward it to the processing stage where I call the processing machine. This machine can be router, radio, or managed switch, and this is where the required space is going to be allocated accordingly to each of the player according to their need. And if all the players are satisfied, then each of them are going to receive the required services. And if they do not satisfy, then the processor has to process it again, and after they are satisfied, then the process will stop. Then this is my flow chart. The flow chart, from the start, the input is going to read the value TC, CS, and SN. Then they are going to form the coalition. After forming the coalition, then the process is going to calculate the coalition function for each of the player. Then after that, then we get the Shapley value. Then if the Shapley value is determined, and then the decision process is going to satisfy, is going to evaluate if all the players has been satisfied. If all the players have been satisfied, then each of them get their required bandwidth, and after getting this, then the process is going to stop. But if each of them are not satisfied, then the process has to start all over from the coalition stage, and then the process continue that way until each of them are satisfied. Then the expected contribution to knowledge here is that this research is expected to introduce a framework for understanding resource distribution in an environment whereby the bandwidth is limited, by integrating the network slicing. Also, it's going to incorporate cache allocation that will provide valuable insight into the optimizing data retrieval. Also, it focuses on maximizing bandwidth utilization while minimizing the wastages. These are part of the references the journals have references. Thanks for listening. Was it 10 minutes? So
what are the methodology of the?
yeah.
Okay,
Maybe stop.